Okay, here we will discuss about the xt and the vt graph for different types of motion. X mean position, t mean time. V mean velocity, t mean time. So xt graph, it is the graph between the position and the time. So usually we take time along x-axis and we measure it in second. And the distance or the positions, it is taking along y-axis and we measure in meter. So the first case is when a body is at rest. Okay, suppose this is a straight line path and let's say a body is moving along the positive x-axis. Now let us say that at a time t equals 0, the body is at this position 40 meter. Okay, so when the time is 0, the body is at 40 meter. When the time is 1 second, the body is again at 40 meter because it is at rest. At 2 second, again 40 meter. At 3 second, 40 meter. At 4 second, 40 meter. So the body does not change its position with time. So in that case, if you join all these points, then you will get a straight line parallel to the time axis. So this is the position time graph for a body at rest. Okay. Next type of graph is when a body moves along a straight line with a uniform motion. Okay. Let us suppose this is the part in which the body is moving. And this body is moving towards the positive x-axis. Now, when the time is 0, the position is 0. When the time is 1 second, then the position is 10 meter. When the time is 2 second, the position is 20 meter. When the time is 3 second, the position is 30 meter. When the time is 4 second, the position is 40 meter, and so on. So this body here is changing its position at an equal amount in equal interval of time. Okay, in every 1 second, how much is the change in distance? 10 meter, 10 meter, 10 meter, 10 meter. So this type of motion is a uniform motion. So when you plot the situations in a graph, then you will find a graph like a straight line passing through the origin. Why do we get this graph? Okay, look. When the time is 0, the position is 0. When the time is 1 second, the position is 10 meter. When the time is 2 second, the position is 20 meter, opposite this. When the time is 3 second, it is 30 meter, and so on. So if you join all these points, then you'll get a straight line graph passing through the origin. So this is a graph for a uniform motion. Alright. Next we will discuss about the velocity time graph for different types of motion. The first type of VT graph is for a positive uniform acceleration. Okay. Again, we consider the motions of an object along the positive x direction. Suppose this is the origin and let us measure the time at this point, and when the time is 0, let's say the velocity of the object is v naught. So in the graph, when the time is 0, the velocity is v naught. Now from here, from this point onward, okay, the body is moving with a uniform increasing velocity, or I can say a uniform acceleration. Okay, uniform acceleration means the body is changing its velocity at an equal rate. Okay, let us say this body continues to increase its velocity uniformly, okay, till a time t is equals to t. Okay, so then the graph, in that case, right, you will get this straight line graph. And this is the initial velocity, this is the final velocity. And at this point, the velocity is v, and this happened at a time t. Okay, so this is the situations for a uniform positive acceleration. Okay, when the body is moving along a positive x direction with a decreasing velocity, and if the body is decreasing its velocity at a uniform rate, then I can say that the acceleration in this case is negative, or the body is deaccelerated, or I can say the body is retarded in this case. Okay, again, this is my positive x-axis, and I consider the motions of the body along this axis. Suppose at a time t equals 0, the velocity of the body is v naught. So at a time t equals 0, the velocity is v naught. And from this point, as the body moves that side, then the velocity is decreasing. And at a time t equal t, let's say the final velocity is v. So because the velocity is decreasing in this case, then this graph, right, it will be falling down in this way. And at this point, let's say the velocity is equals to v. Okay. Okay. So this is the situation when the body is moving with a uniform negative acceleration. So we get this type of graph. The next VT graph is when the body is moving along the negative sides of x-axis. Okay, so in that case, the velocity, right, will be below the origin. That means along the negative of y-axis. So consider this case that when the time is 0, the velocity is equals to v naught. So when the time is 0, the velocity is v naught. And from this point, the velocity starts moving towards the more negative sides of the x-axis with a decreasing velocity. So as the velocity decreases, then these lines will fall down like this, and up to a time t is equals to t, the final velocity becomes v. So it falls, and then up to this point, the time is equals to t, and the final velocity is minus v. So this type of situation, it is a VT graph for a body moving along the negative side, body moving in negative x direction with negative acceleration. Okay, with negative acceleration. So this is the type of a graph that we are getting in this case. Okay. Okay, another graph is we consider the motions of a body that starts from the positive sides of x-axis. Let's say, okay, at time t equals 0, the velocity of the body is v naught. And this body, it is on the positive sides of the x-axis. Now, the body is moving towards the origin, okay, with a decreasing velocity. So as the body moves towards the origin with a decreasing velocity, then in the graph, that situation is this. At time t equals 0, the velocity is v naught. As the time is increasing, then the velocity is falling down, decrease, and it reaches 0 at this point. So at this point mean at a time t1. So when the time t is equals to t1, then the velocity becomes 0. Okay. If the body continues to move along this side, now it comes on the negative of x-axis. So if the body continue to move in this case, then again, right, the region it will be in the negative side. So that means it keeps on decreasing its velocity till this point. Let's say the final velocity is v. Okay, this is v, and let us say this happened at a time t is equals to t2. Okay, so from this point, which is corresponding to the origin, now if the body decreases its velocity, then the velocity will, this line will fall down till here, right, where the velocity is v, final velocity. And this final velocity, it happens at a time t2. And please note down, I wrote minus here because the velocity is on the negative sides of the x-axis. Because velocity, right, it may be positive or negative depending upon the signs of displacement. For displacement, when the body move on the x, on the negative of x, then we have velocity as negative value. Okay, so these are some of the xt and vt graph for different types of motions of a body.